Have you ever pondered the enormity of the universe and its countless mysteries? This vast expanse of space we inhabit is filled with wonders that challenge our understanding and push the boundaries of our knowledge. Among these marvels, black holes stand out as some of the most intriguing entities. These celestial bodies create a gravitational pull so strong not even light can escape their grasp. Black holes are the universe's enigma, a paradox of space and time that has captivated scientists and astronomers for decades. Their existence poses questions that lead us to the very edges of physics and beyond, into a realm where our common understanding of reality is turned on its head. And within this, there's an even more fascinating phenomenon: binary black holes. These are pairs of black holes locked in a cosmic dance, their gravitational forces pulling them towards each other in a spiraling embrace. One of the most captivating phenomena in our universe are binary black holes. Let's dive into the top 10 discoveries we've made through observing these extraordinary entities. Starting from number 10, we have the very discovery of binary black holes. The existence of binary black holes, two black holes in a close orbital dance, is a thrilling revelation in the field of astronomy. These cosmic phenomena were first theorized in the late 20th century, yet their existence remained unproven until the 21st century. Binary black holes are not just two black holes in close proximity to each other. They are gravitationally bound, constantly moving in a dizzying dance that sends waves of energy rippling through the fabric of space-time. Their significance is immense. They help us understand the fundamental aspects of our universe, including the nature of gravity, the life cycle of stars, and the dynamics of galaxies. The discovery of binary black holes has sparked a revolution in astrophysics and cosmology. It's like finding a new key to unlock the secrets of the universe. This discovery opened a new chapter in our understanding of the cosmos. At number 9, we have the detection of gravitational waves. As we journey deeper into the cosmos, the merging of binary black holes has given us an intriguing gift: gravitational waves. These ripples in the fabric of space-time are akin to the ripples created by a stone thrown into a pond. Except in this case, the pond is the universe, and the stone is the immense energy released by colliding black holes. Albert Einstein first predicted the existence of these waves in his general theory of relativity, but it wasn't until a century later, in 2016, that they were finally detected by the Laser Interferometer Gravitational Wave Observatory, or LIGO. This discovery opened a new window into the universe, allowing us to observe cosmic events that were previously hidden from us. Gravitational waves carry with them information about their cataclysmic origins and about the nature of gravity that cannot otherwise be obtained. The detection of these waves has provided us with a new way to observe the universe. Our 8th key discovery brings us to the intriguing concept of the mass gap between neutron stars and black holes. This gap refers to a peculiar absence of observed objects with masses between approximately 2 and 5 solar masses. In other words, we see neutron stars that are lighter than about 2 suns, and we see black holes that are heavier than about 5 suns, but we don't see much in between. So why is this important? Well, the mass gap challenges our understanding of how stars die. Our current theories of stellar evolution predict that when massive stars exhaust their nuclear fuel, they should leave behind either a neutron star or a black hole. But the mass gap implies that there's something we're missing, some process or mechanism that we don't yet fully understand. This discovery has challenged our understanding of stellar evolution, and it's a puzzle that astronomers are eager to solve. At number 7, we have insights into the merger processes of binary black holes. This fascinating dance of cosmic giants is a spectacle to behold, even though we can't see it with our naked eyes. The process starts with two black holes orbiting each other. Over time, they lose energy through the emission of gravitational waves, causing them to spiral closer and closer together. This process accelerates until they finally collide and merge into a single, larger black hole. These events, known as black hole mergers, release a tremendous amount of energy, more than the combined light from all the stars in the universe. This energy is what powers the gravitational waves we detect here on Earth. The resulting black hole settles down into a stable form, a process known as ringdown. It's like a bell ringing out across the universe, a signal of one of the most violent events in space. These mergers are amongst the most violent events in the universe. Number 6 on our list is the discovery of high-speed jets emitted by binary black holes. Picture this: 2 black holes circling each other, their immense gravity pulling and playing with the very fabric of space-time. And in this chaotic dance, they release powerful streams of matter and energy, shooting out at nearly the speed of light. These are the high-speed jets we're talking about. The discovery of these jets was a monumental leap in our understanding of black holes. But why are they so important? Well, these jets are the black hole's way of interacting with their surroundings. They heat up interstellar gas, influence star formation, and can even alter the evolution of entire galaxies. By studying these jets, we're able to gain insights into the extreme physical conditions present near black holes. It's like having a front-row seat to the most energetic events in the universe. These jets give us crucial information about the extreme environments surrounding black holes. Coming in at number 5 is the discovery of black holes' spin rates. By observing binary black holes, astronomers have unlocked the ability to measure their spin rates. But what exactly does this mean? Well, the spin rate of a black hole is essentially its rotational speed. It's a fundamental property, much like mass or electric charge. What's fascinating is that the spin of a black hole isn't just idle information. It can tell us a lot about the black hole's past. For instance, black holes formed from collapsing stars will have a spin rate influenced by the rotation of the original star. On the other hand, those resulting from the merger of 2 black holes may exhibit different spin characteristics, reflecting their violent origins. So by studying these spin rates, we're not just learning about black holes as they are now, but also gaining insights into their intriguing histories. The spin of a black hole can provide clues about its history. Number 4 on our list is the discovery and study of event horizons. Now, this is where things get even more intriguing. An event horizon is a point of no return. It's like a cosmic boundary, beyond which nothing, not even light, can escape the gravitational pull of a black hole. In the case of binary black holes, each black hole has its own event horizon. But as they spiral closer and closer, these event horizons begin to merge, forming what's known as a common event horizon. This is a critical point in the life of a binary black hole system, marking the irreversible moment of their union. And here's the kicker. While we can't see the event horizon itself, we can observe its effects on the surrounding space. This has opened up a whole new avenue of study, providing key insights into the nature and behavior of black holes. Event horizons are key to understanding the nature of black holes. At number 3, we have the discovery of different black hole populations. This remarkable finding has significantly advanced our understanding of the cosmos. Black holes, as we know, are not all created equal. They come in different sizes, from stellar black holes with masses up to 20 times that of our Sun, to supermassive black holes weighing millions or even billions of solar masses. But there's more to it than just size. Astronomers have also identified different populations based on their location within galaxies. Some black holes reside in the bustling centers of galaxies, while others prefer the quiet outskirts. This fascinating diversity has led to a better understanding of how black holes form and evolve over time. Moreover, this categorization has shed light on the complex dynamics of galactic centers and the role black holes play within them. From influencing star formation to driving galaxy evolution, black holes are pivotal players in the cosmic theater. This discovery has broadened our perspective of the universe's complexity. Our second top discovery is the observation of ripples in space-time. These ripples are like the cosmic equivalent of ripples spreading across a serene pond after a pebble is tossed in. But in this case, the pebble is a pair of spiraling black holes, and the pond is the very fabric of our universe. These ripples, known as gravitational waves, are disturbances in the curvature of space-time. They were first predicted by Einstein's theory of general relativity, but it wasn't until the detection of binary black holes that we had hard evidence of their existence. The creation of these ripples is a cosmic event of unimaginable scale, a dance of gravity involving masses millions of times that of our Sun. The discovery of these space-time ripples has profound implications. It has opened up a new way for us to observe and understand the universe, allowing us to detect events that would be invisible in the light we traditionally use to observe space. These ripples have revolutionized our understanding of the universe. And finally, our most significant discovery is the direct observation of black holes. This breakthrough, my friends, is indeed a landmark in the history of astrophysics. The direct observation of black holes, something once thought to be impossible due to their light-swallowing nature, has now become a reality. This discovery has allowed us to glimpse into the heart of these cosmic behemoths, providing us with valuable data and insights. The images captured have confirmed the predictions of Einstein's general theory of relativity, showing a fiery ring of gas swirling around a circular shadow. This shadow, my friends, is the event horizon of the black hole, the point of no return. But the implications of this discovery go beyond just confirmation of theories. It has opened up a whole new playground for physicists, allowing them to test and refine their theories in extreme conditions. It has also sparked countless more theories and questions about the nature of our universe. This observation has confirmed many theories and sparked countless more. So there you have it, the top 10 discoveries from observing binary black holes. Let's take a moment to reflect on this thrilling journey we've embarked upon through the dark and mysterious realms of the cosmos. We've delved into the intricate dance of binary black holes, their existence forever shaping not only our understanding of the universe, but also our place within it. We've unraveled the riddle of gravitational waves, these elusive ripples in the fabric of space and time, forever echoing the cosmic ballet of these celestial giants. They've proven to be not only a testament to Einstein's genius, but also a new way for us to listen to the universe's symphony. We've explored the enigma of the mass gap, that perplexing zone between the heaviest neutron stars and the lightest black holes. This gap continues to challenge our understanding and keeps us at the edge of our seats, reminding us that the universe is full of surprises. We've witnessed the mesmerizing merging processes of binary black holes, a cosmic spectacle of such grandeur and power that it literally shakes the universe. This cataclysmic event not only forms a bigger black hole, but also releases a tremendous amount of energy, further fueling our curiosity and wonder. We've also examined the high-speed jets, the spin rates, the event horizons, and the various populations of black holes, each one illuminating a different facet of these fascinating celestial objects. And we've seen space-time ripples, the universe's own way of telling a story of cataclysmic events, a tale that we are only beginning to decipher. Lastly, we've celebrated the direct observation of black holes, a monumental achievement that has thrown open the doors to a new era of astronomy, an era where we not only see but also hear the universe. These discoveries are not the end of our quest, but merely the beginning. They beckon us to push the boundaries of our knowledge and to venture further into the cosmic ocean. As we continue to gaze into the cosmos, who knows what other mysteries we might uncover. Thank you for joining us on this incredible journey through the mysteries of the universe. If you've learned something new, if your curiosity has been ignited, if your perspective of our place in the cosmos has been broadened, then we ask you to support our endeavor to bring more such content to you. Please give this video a like and share your thoughts and opinions in the comments section below. We value your insights and are excited to engage in discussions with you. Don't forget to subscribe to our channel and press the bell icon to receive notifications for our upcoming videos. This journey through the cosmos is not one to be undertaken alone, so please share this video with your friends, families, and fellow space enthusiasts. Together, let's continue to unravel the mysteries of the universe and venture further into the cosmic ocean. Until next time, keep looking up.